Hey guys, so we are going to be going over the enzyme section now, which is really, really good. So let's start off with number one. What type of biomolecule is an enzyme? Now, enzymes are a specific type of biomolecule. We only had four. We had carbohydrates, lipids, proteins, and nucleic acids. Enzymes fall into the category of proteins. Now let's go to number two. What is the job of an enzyme? Use the vocabulary catalyzed. So enzymes catalyze reactions. That means that they speed up reactions. They speed up reactions. Now let's go to number three. How do enzymes catalyze reactions? Use the term activation energy. Okay, enzymes are able to catalyze reactions by lowering the activation energy. By lowering the activation energy. And if we don't remember, let's make sure we get this down right now. Activation energy means the amount of energy you need to start a reaction. The amount of energy you need to start a reaction. So they lower the amount of energy you need to start a reaction. And they can do this by doing part of the job of the reaction. But there's a clear distinction that we're going to come up right now. So make sure that we get this down because this was a clear misconception that I noticed from you guys that I don't want you to mess up on. Here we go. So we have image 2 right here, image 2. In image 2, which of the reactions, the lines, has an enzyme working with it? And how do you know this? Okay, so we just said that enzymes catalyze reactions by lowering the activation energy. So if we find an enzyme, the activation energy must be lower. And from what I can see, red has a really big spike, while blue has a much smaller spike. And this right here, this distance is the activation energy. And since blue has a lower activation energy, then that must mean that an enzyme is present there lowering the activation energy. So the smaller hump is always going to have an enzyme working on it because it's lowering the amount of energy you need for the reaction to happen. Now we're going to go here. So we have this temperature right here. Yeah, this little nice looking temperature. And then we have this pH right here. Again, another nice little looking pH. What is the optimum temperature for the enzyme above? Okay, let's go back. From what I can tell, this is roughly speaking about 38 degrees Celsius. So the optimum temperature is 38 degrees Celsius. But let's remember this. Optimum temperature means the best temperature, not the biggest number. I'm saying this loudly because this was something that we messed up on. It is not the biggest number. Look over here. The biggest number right here is 61. And when it's at 61, the enzyme is dead. It's not working anymore. We can also see that we have different numbers like 10, 20, 30, 50, 60. These are not the best numbers. The peak, the one we're doing the most work, is at the optimum temperature, which in this case is 38 degrees Celsius. Now, what is the optimum pH? Same deal. When we go over here, we can see the optimum pH is about 7. That is the best pH because optimum means best. We have bigger numbers like 8, 9, 10, and 11. They're not the optimum. They're not the best number. The reaction rate goes down. We also have ones like 3, 4, 5, or 6. They're still not the best because the reaction rate is not as high as when it is at 7. When it is at 7, that is the best for the reaction rate. Which of the following would be the best environment for enzymes to do its activity? It's activity. Whoa, that's a vocab term. And that's an important vocab term at that. Activity. Activity, we define it as its job. An enzyme, whenever it does its job. So which environment would let it do its job the best? Okay, so in this case, it would have to be pH 7 and at around 38 degrees Celsius. So let's go back down. And this, from what I can see, it is actually answer number 1 because that is the exact optimum environment for it. Next question. Do enzymes always break something down? This is a tricky question that I know a lot of you just got wrong. Enzymes do not always break something down. What they do is they speed up a reaction by lowering the activation energy. So what that means is it depends what's going on in the reaction. Remember this. We have these terms like substrate. Substrate is one of those terms that we had. The substrate goes into the enzyme, but you got to remember, it depends on what the job that's happening is. So for example, right here, let me see if I can write down real quick. If the job of the enzyme, like this one right here, is to take in the substrate, I'll do this one right here, is to take it in and then break it down. into two things, then yeah, that enzyme's job is to break something down because that's what's going on in the reaction. We're breaking down one thing and making it into many. But if the job of the enzyme is different, let's say it's this enzyme, and its job is to take in two things and go ahead and make one, then that's not breaking down something, that's creating something. See, all that enzymes do is they help the reaction do its job. That's what an enzyme is supposed to do, help a reaction do its job. So if the reaction's job is to take one thing and break it down, then yeah, they'll be breaking something down. But if the reaction's job is to take two things and combine them into one, then no, it's not going to break something down because enzymes only assist with what's going on in the reaction. Now let's go down a little bit. Okay, when I say enzyme activity, what am I referring to? Oh, that's pretty simple, guys. Enzyme activity is the job of the enzyme. Just like how we were saying, the enzyme's activity is the amount of its job that it's doing. So back with that example that we gave, like we wrote right here, if the enzyme's activity is to destroy one substrate and make new products, then it'll do that. Or if its activity is to take two substrates and create a new one, then it'll do that. But an enzyme's activity is referring to its job. It's what it's doing in the reaction. And that all depends on what's happening in the reaction. Are we breaking one thing to make more things, or are we combining some things to make one thing? All depends on the reaction. Last question. What happens when an enzyme denatures? All right, this one's actually not too complicated. When an enzyme denatures. So let's actually go back. Now, there are a couple things that can denature an enzyme. For example, when the temperature is too hot, guess what happens? It goes down and down and down. And then eventually you get to a point where, boom, it's not doing its job anymore because you broke your enzyme. You broke it. You made it too hot and you made it twist and you made it change shape and it can no longer do its job because enzymes are very, 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 very specific. They have a specific shape because they do a specific job. And if you heat it up too much, it will no longer be able to do its job. Think about it. It's like if I took a paper clip and I put it under a fire. Eventually, it would start to melt and it would be changing shape. And then guess what? My paper clip would not be able to do its job, which is to hold paper anymore, because its shape has been permanently altered because it was too hot. Same thing with pH. Check it out. At pH 11, you've changed the environment so much that you've literally changed the shape of the enzyme. And when you change the shape of it, when you denature them, they cannot do their job. So, what happens when an enzyme is denatured? You ruined your enzyme. You've literally changed it so it cannot do its job anymore. And that's a bad thing. That's why you want to have those optimal environments instead of those unoptimal environments. Because if you put something in a bad enough environment, you will destroy your enzyme and it will no longer be able to do its job anymore. And with that being said, guys, that is it for this section. And I will see you guys in a bit. Bye, guys.